quadratic equations. With solving quadratic equations, they're equations. They're set equal to 0. When we solve quadratic equations, what we are finding is called a root. A root is the value of x when the equation equals 0. So we are going to be finding roots. So sometimes it'll say find the roots, sometimes it'll say find the solutions. Okay, solutions, roots mean the exact same thing. We may also find roots if it's a function. And this is where it starts to get confusing, is what's the difference between equations and functions. So that's why I put zeros up here as well. Zeros is just another name for the x-intercepts. So if I tell you to find the zeros of a function, you're finding the x-intercepts. But I also could ask for the roots of a function. Roots of a function, if it's a function, are exactly the same thing as zeros, which are exactly the same thing as x-intercepts. Because the definition of a root is very general. Very, very general. It's the value of x when your equation equals 0. So if I need to find my x-intercepts, I set my quadratic equal to 0. That's why roots are also a subset in zeros and x-intercepts. But x-intercepts, obviously, are for functions only. Roots are for equations and functions. So thinking big picture. Zeros will always be coordinate points. That's the other thing to remember. Zeros will always be coordinate points because it's the x value, comma, 0. And then roots will always just be x equals, unless we then have to apply that to a function, then we can write it as a coordinate point. But these typically are x equals, zeros are typically coordinate points. We're going to focus on the roots. So we're going to be solving all of these, we're going to find solutions. All of these are going to be just equations, not functions. Again, function means there's a y in there. So to begin with, we are going to solve these by factoring. So I'm going to pause this here. You guys should all be really good at factoring. So go ahead and factor those 3 problems and then set those factors equal to 0. Okay, so when we start factoring these, hopefully you realize this first one, you can shortcut this one because the leading coefficient's 1. So instead of having to do the x in the box for this one, since the coefficient's 1, you can just do your product and sum. So your product for that is 6. Your sum is 5. What 2 numbers were?
2 and 3.
2 and 3. You do not want to have to do the x in the box for that. Okay, it's going to take you way too much time. So now you do the zero product property. Set each factor equal to 0. So x plus 2 equals 0 and x plus 3 equals 0. That's the whole point of why we factor. Because the zero product property happens. If this is 0, then this goes away. Or if this is 0, then this goes away. So therefore, when you solve, you get -2 and -3. In part B, there's a leading coefficient, so you can't shortcut that one. Unless you can just visually see it in your head. Product is a times c, so your product is -8x squared. Your sum is -7x. So what we're trying to do right now is we're trying to fill in these 2 terms in our box. So therefore, what 2 numbers multiply to give you -8x squared and add to give you -7x?
8x and -x. I mean, yeah.
Since my sum though has to be negative,
Yeah.
the 8x has to be negative. So toss those guys in. And then we factor. Factor out an x. X times what is 2x squared? 2x. X times what is x? 1. Factor out a -4. Double check. -4 times 2x is -8x. And -4 times 1 is -4. So all we did was factor so we could rewrite. We haven't done any solving yet. Now we can solve, we can do the zero product property, setting each of those factors equal to 0, which means x equals -1/2 and +4. And then the far right one, there is a leading coefficient, so you can't shortcut it. But the third way to factor is what some of you guys like to do in terms of guessing and checking. You can guess and check your factors. It goes a lot quicker. You just have to think about what do you need in order to get the numbers. Now this one is a perfect guess and check problem because it's a special type, and you'll see it once we factor it. But one of the things that you'll notice is this is a perfect square and that's a perfect square. But otherwise, what I have to figure out is what times what gives you 9x squared. 3x and 3x, or 1x and 9x. Those are my only two options. But even better, how do I get a positive 1 at the end? Either 2 positive 1s or 2 negative 1s. That's it. So your options are really limited with what you have. Now those last terms have to be positive 1s because there's no subtraction in here at all. So what ends up happening is you kind of are guessing what you think they are, and then you check your math. 3x times 3x is 9x squared. 3x times 1 is 3x. 3x, that gives you 6x, and 1 times 1 is 1. And what this ends up being is a binomial squared. 3x plus 1, quantity squared. And we'll look for that in certain problems. Here's the thing though. If you don't see it, X in the box. You've got this method you can always fall back on. We set each of those equal to 0 and we get x equals negative 1/3. Twice, but we'd only write it once. So what's really nice about today's lesson is you've learned all of this. Now start to look for what makes it the quickest, what makes it the easiest. I'm going to expose you to all of it, and you get to go through and go, I absolutely am not going to do it this way. Like some of you are not going to be able to see the way we just did it here, and you're like, I can't do that. That's fine. Don't do it that way. Do it this way. Do it like me. It's completely fine. It's just going to take you some more time. Try to save those of you the time that can do it to be able to work through those processes. And if you don't see it, that's perfectly fine. Don't fret. Okay. So, that's the first part with factoring. The second one, so now I just said find the roots. Just like I introduced before, roots are the same thing as solutions. So find the roots of these equations using the factorization method. So we're going to do this by factoring again. What has to be true in order to factor it? It all has to be set equal to 0. It has to be set equal to 0. Then I can look at those factors. So you are going to have to expand out sometimes like you are in B. But you are going to have to move everything to the one side and factor. So go ahead and take a few moments to do A and B. So now that we have them set equal to 0, it's just like we did before. If there's a leading coefficient, do your x in the box, or look for some other shortcuts that might happen nicely. And otherwise, do shortcuts if your leading coefficient is 1. So, just to save time, this one factors. 3 is a prime number. I'm going to go through the shortcut with you again. 3 is a prime number. The only two options, therefore, are 3x and 1x. Then I have to figure out which ones work here between these two. My product is negative, or my last term is negative, so one's a positive, one's a negative. So it can be 1 and 12, 2 and 6, 3 and 4, in any of those orders. So there's 6 different possible factors that you could do with this. When you go through that process, it ends up being a positive 2 and a negative 6. Because you also have to check the negativities. And again, if you're unsure, 3x times negative 6 is negative 18. And 2 times x is positive 2. Negative 18 plus 2 is your negative 16. 2 outsides plus the inside. Okay, so therefore x equals negative 2/3 and positive 6. In the last one, leading coefficient's 1. That one makes factoring so much easier. N. Make sure you use n's since n's are in the problem. You have to use n's in your answer. Product is negative 10, sum is 3, two numbers that work are a positive 5 and a negative 2. Since my sum is positive, my bigger number has to be positive. And again, all we did was rewrite. Now we can solve. N is negative 5 and positive. Questions on factoring, using factoring to solve. So that's one option to solve quadratics. Again, just trying to get you guys to kind of think through these. Next one, this is a different type of looking problem. But I don't want you to set them equal to 0. Again, I'm trying to expose you to as many different options as possible. And if you didn't set these equal to 0, you would have to do the quadratic formula, which we're not getting into until Monday. So another option to solve these is to completely ignore this right side and look at x squared plus 10x plus 25. X squared plus 10x plus 25 is x plus 5 squared. Because when I expand that binomial squared, I square the first term, I square the last term, I multiply these two and double it. So if you can see it's a binomial squared, this problem is much easier than having to do the quadratic formula. I tried to convince you of this in Algebra 2. Most of you don't agree with it. And again, when a push comes to shove in the end, if you don't like this method, you don't have to use it. But it is really helpful because you typically will have your radical simplified as well. How do I undo a square? So therefore, x plus 5 equals the positive and negative square root of 11. Then what do? Subtract the 5. See how easy that is? If you see it. If you see it. Because that left side was a binomial square. If you can't get to that step, then it's really hard to see, and I totally understand. So I want you guys to figure out, what do you think B, what binomial square do you think B is? Okay, so what is this binomial square?
Plus 2 or minus 2.
Minus 2, good, square. Because of that subtraction there, you really are square rooting your first and last term, and then you're going to see if you get that sum in the middle. And that equals 8. And just like before, we square root both sides. One's a positive, one's a negative. Add that 2 over. And then you're all going to yell at me because square root of 8 is not simplified. What perfect square goes into 8? Divides into it. 4 does. Square root of 8 is equivalent to the square root of 4 times 2, which is equivalent to the square root of 4 times the square root of 2, which is equivalent to 2 times the square root of 2. Breaking down your radical. And then the number in front is a 2 as well. Because that's just what it was to begin with. All we did was break down that radical.
That's really necessary?
Yes, it is. That's simplifying.
No.
It
But
is.
it's, I don't get it whenever you do that.
The next way to solve is by completing a square. Okay, math teacher here. I can totally complete the square. I hate completing the square. I know it's shorter in some cases. I don't like completing the square. I can do all of these problems without having to complete the square. I am more than happy to use any of the other options available to me, except I don't want to do this one. But I'm going to show it to you because some of you like this method. I think you're crazy, but you like this method. But I'm going to also point out flaws to it. So if you really do like this method, that is fantastic, but you need to know when it does become a lot more of a headache than a positive, especially on a no calculator assessment. So when we look at completing a square, we did this in Algebra 2 with putting things into graphing form, where it was a function, where it was a y equals. Now we're going to solve this way. I'm assuming in Algebra 1 you guys use completing the square to solve. The likelihood that you remember that is slim, but maybe you kind of do a little bit. But what happens with completing the square? Our book does this, by the way, a different way. I'm more than happy to go through another option with you. There's a couple of different ways to complete the square if you really want me to teach them to you. I don't know. I think the way that we do it with the box is the easiest to see it, in my opinion, but that's kind of up to you as to what you see as well. So when we complete the square, we look at our first and second term. We look at the ax squared plus bx, and that's the part that we complete. So in the first box is the x squared. Folks, that has to have a leading coefficient of 1. If it doesn't, we have to get rid of that coefficient, because otherwise the factoring does not work. And then, because I'm completing the square, I need this factor up here and this factor over here to be exactly the same. In order for that to happen, my b value, negative 6x, half of it has to go in this top box, and the other half has to go here. second factor out an x. X times what is x squared? That's x. X times what is negative 3x? That's negative 3. Since I'm completing the square, I'm getting a binomial squared. If that's minus 3, then this has to be minus 3. We're doing area modes, length times width. So negative 3 times negative 3 is this box here, which is 9. I showed you a different way to do this in Algebra 2. With equations, it's easier. Because what I have here is x minus 3 squared. That's my binomial squared. But the problem is x minus 3 squared, I'm just going to write this out. You guys don't have to write this out. X minus 3 squared is x squared minus 6x plus 9. But there was no plus 9 here. How can I add a 9 on this left side of my equation? Yes. Say that one more time.
So you'll have x minus 3 in parentheses and you'll put negative 9 after it or something?
That's one option, yes. And that's what we did in algebra 2, yeah, for functions. So if we added in the 9, then we had to subtract out the 9. So one option is, okay, if I'm going to add a 9, I'm going to subtract out a 9. Or if I add a 9 to the left side, because that's what this did here, right? It added a 9. If I add a 9 to one side, I have to add it to the other as well. I'm going to take this bottom stuff out in just a second. Because I started with this, x squared minus 6x. We completed the square, we got this with it. The problem with that is it brought in this 9. So I then have to subtract out that 9 or add it to the other side. You choose which way you want to do it. Most likely because you're solving, you probably want to get it on the other side, because now it's going to look like this problem did. You'll have a binomial squared equals something. So this was just a setup to get to solving. This is why I don't like completing the square. I think there's more work in it than you have to do. But once you get here, it's really easy. What do you do to both sides? Square root, positive and negative, add your 3. Once you have a binomial squared, your solving process is much easier. And that's what completing the square is helping you do. I think more of you will be successful with the quadratic formula, because we're going to use the quadratic formula a lot. In part B, that was only A. In part B, why don't you guys go ahead and try to complete the square with B? B is much easier than C. C is tough. Okay, so for completing the square on this one, I just move the 21 over to the other side, and then I look at what binomial squared. It's x plus 2 squared. Because in my head, I know that x plus 2 squared is x squared plus 4x plus 4. So it brought in a 4 on that left side, so therefore I have to bring in that 4 on the right side. So x plus 2 squared equals 25. Square root both sides. That's a nice perfect square. And then subtract the 2. So 5 minus 2 is 3, and negative 5 minus 2 is negative 7. Now that one you could have factored, and you'd have gotten to the same answer. Product's negative 21, sum is 4, and then go from there.
Where did the 4 come from?
Right here. X plus 2 squared is x squared plus 4x plus 4. So I added the 4 on this side, so I add the 4 on that side.
Oh, I see.
Okay, then the last one. So for this one, my middle term is not nice. It's a fraction. So I get x squared minus 5 halves. not x squared, x minus 5 halves, quantity squared. What you'll notice is that always ends up being half of whatever b is. It's half of b. Because you have to add two of them together. Because negative 5 halves plus negative 5 halves is negative 10 halves, which is negative 5. That ended up adding in, though, negative 5 halves squared, which is 25 fourths. 25 fourths is 6 1/4.
Yeah.
So therefore I have to add 6 1/4 over here. And I keep going. And I know I'm going to lose some of you at this point, and don't worry, I can totally lose you because you'll never have to do this. I'm not going to force you to. Let's see, that's 13 fourths. That's the square root of 13 over 2. Which you can write it as one fraction, it really doesn't matter. Either of these work. You can't have the square root of a decimal though. It's not simplified. For a final answer, that is. If you're looking at it going, how did you do that? You know what? You're already the person that's going to do the quadratic formula on that problem. I would never complete the square on this problem. I'm going to do the quadratic formula.
Quick question. This is sort of like a loaded question.
Our textbook is really mean and says, hey, complete the square with these as well.
No.
Now, the first one actually is not hard to do. The first one is actually easier than part C was in the last one. Part B, I would never complete the square on. The reason part A is really easy to complete the square on is this is an equation. What can I do to all three of those terms? Divide them all by 3. And you get x squared plus 4x equals 6. And now all of you can complete the square on that. You get x plus 2 quantity squared. That brings in a 4. Therefore, add that 4 to the 6. So x plus 2 quantity squared equals 10, square root both sides. No perfect square divides into 10, so that's simplified. Subtract your 2. The last one, I would not recommend completing the square on, unless you're just really good at it. So if you remember the quadratic formula, you can go ahead and practice the quadratic formula. I will complete the square just because it asks us to. But a quick note for you. If you want to complete the square, the leading coefficient of x squared has to be 1. You cannot do it if there's a coefficient there. So you have to divide both sides by 4. You have to. And what it typically does is it gives you all fractions except for that one term. In this term, it just so happens that b is nice. So that gives me x minus 1 squared. That brought in a 1, so I have to add the 1 to the other side. Simplifying it. Add the 1 over. So here's where the problem comes in. Not only does it get harder with completing the square when there's fractions, you can't have a radical in your denominator. You can't have a radical in your denominator. Therefore, you have to multiply this by a form of 2. A form of 1, which is 2 over 2. Alright, I can multiply anything I want by a form of 1. Because that gives me 10 over 4, and 4 is that perfect square. If you wanted to make it into a fraction, just make the 1 2 over 2, and then you combine them. If you did the quadratic formula correctly, you get that. But what I want you to look at now is I want you to look at what do the problems look like that got us to start trying to do different things. Our textbook gave us problems that fit each of the different types of problems to try to make you see, like, when would you use this, when wouldn't you use this, along with my interjections along the way. So these type are factored. You're factoring these problems. You can see your product and sum. Factoring is really nice when the leading coefficient is 1. When your leading coefficient is something other than 1, you can still factor because it takes you a little bit more time. In part C, we're getting that binomial squared. That binomial squared is sometimes that you can see by guess and check. And the second types of problems, we did exactly the same thing. We just had to set them equal to 0 though first. Okay. These two problems we were looking at, the left-hand side was already in perfect square format. You just had to find what the perfect square was for your binomials. Because once you have that, you can quickly square root both sides, positive and negative. In these problems, the only one that actually factored was B. You would not be able to solve this problem or the other two problems by factoring. So what are my options? Well, if you can't factor it, you can complete the square, or you can do the quadratic formula, which we're focusing in on Monday. What is completing the square nice? When your b value is the coefficient of x, is even. And when your leading coefficient's 1. Just trying to get you to start seeing that. If your leading coefficient is something other than 1 and you want to complete the square, you have to divide it out. Completing the square is a bit easier with equations than with functions, because you can just move it always over to the other side, divide it through, get rid of it. But the work behind it can get a little messy, especially when you look at simplifying properties. You cannot have a square root in the denominator, which is what this step had. That had the square root in the denominator. It's the square root of 2. So multiplying by forms of 1 to make it a little nicer. Okay. So I'm going to give you a mix of problems that are going to practice all of these different things from factoring on. Starting with 3p is 1AEF, 2ADB. 3q, 1BDF. I need you guys to ask me about D on Monday. There's something special about D. Totally do D normally, but ask me about D on Monday. 3R, 1 and 4. 3S, 1, 3, and 6. And 3T, just number 7. No completing the square with it, if you don't want to. I mean, if you want to, you can totally do it, but it says complete the square. Solve it however you want. I don't really care which way you do it. But if you're good with completing the square, then go ahead and do completing the square. Okay, so go ahead and practice these problems, making sure that you understand pros and cons.